Hey guys, Mr. Middleton here, and we are on our third lesson in Algebra 1, talking about solving equations. Okay. Alright, so after this lesson you should be able to solve equations with variables on only one side of the equal sign, and then you should be able to use the distributive property to solve equations. Alright, at this point we're going over it because it's a really important part of algebra, but this should hopefully be review for most of you. Okay, so let's talk about it, make sure that we're on the same page. To solve an equation, you need to isolate the variable. Okay, that's what solving the equation means. And that just basically says get the variable on a side, on one side of the equation by itself, or one side of the equal sign. To do this, you have to move the numbers on the same side of the equal sign to the opposite side or other side. And we do that by using inverse operations, the inverse operation. Okay, and so let's do that. Remember the inverse operations, what that means is the opposite of it. So if I'm adding the inverse, I should do operation and then the inverse will be subtraction. If I'm, again, I guess the same way, if I'm subtracting, the inverse would be addition. If I'm multiplying, or something's being multiplied, then the inverse should be division. And same thing here, division, the inverse is multiplication. There are more inverses like squares and radicals, and we'll talk about those later. But these are the inverse operations that we probably really have to worry about now. And so let's get to some examples. First one, starting off pretty basic. We have x plus 6 equals 11. We need to solve for x. So again, we want to get x by itself on this side. We'll move the numbers to the other side by using inverse operations. So we're adding 6. The sign in front of the number that we want to move is really important. So that means to get rid of it, we need to subtract 6 from both sides. Okay, and what that does, x is on the side by itself equals 5. And that's our answer. Okay, need to make sure we get in the habit of actually going through and subtracting these. A lot of bad habits happen where people will think they're doing something right, so they see it's plus 6, they plus 6, and they just cross it out because they expect it to work. But double check your work, be slow about it, especially in the foundation of this class, to make sure that you understand how things are happening. Alright, number 2, it's a little bit trickier, more tricky of a problem. Let's get x by itself. So we have to ask ourselves, what is stopping x from being by itself? And with all these things, you really want to work outside in. Or if you want to think about it, our order of operations is PEMDAS. When we solve, we usually go in the opposite direction. Okay, SADMAP. Okay, you can think about it as tying a knot. When you tie a knot, you do one thing, but when you untie the knot, you have to go in the opposite direction. So if you pull really tight to tie it, you kind of push things and try to pull things the opposite direction to untie it. And that's what we're doing with these equations. So, really work from the top up, or top down, or bottom up, whichever one you're looking at here. And we need to get rid of this 3 first, okay? Because this 3, what's this 3 doing to our 4x? It's adding. And so we need to subtract 3. And we can tell this is adding because there's an understood positive sign here. Remember, it's the sign in front of the number that really matters to what we are going to do to it. So we have negative 4x equals negative 20. Now we need to get x by itself, okay, because when we subtracted, 3 minus 3 gave us 0. We are left with this thing. We didn't touch this negative. So we divide by negative 4, and when we do that, we have x equals, it's going to be positive 5. Okay, so x equals positive 5 because a negative divided by a negative is positive. Okay, in these first two problems, x came out as 5. No, every problem won't come out as 5. Okay. Alright. Number 3. 2/3 x plus 7 equals 13. So, our first step, again, we're working backwards, subtraction and addition first, so we need to subtract 7. That's the inverse operation of that addition sign in front of 7. Get 2/3 x equals 6. Alright, so we got that done. And now we need to get x by itself. Now, don't let the fraction fool you. Don't let it make it feel too difficult here. Remember, in order to get rid of a fraction, or actually, let's talk about this. These two numbers are being multiplied. Okay? So in order to get rid of it, we need to divide. It means we're dividing by 2/3. When we divide by a fraction, that means we're multiplying by its reciprocal. So what I'm going to do is I'm going to multiply both sides by 3/2. Okay, and I'll show you why we do this. So this will take a little bit longer, but hopefully it'll give you a good reasoning for why we do this if you didn't have it. On the left side, we have 3 times 2 on the top. That's how we multiply fractions, numerator times numerator, denominator times denominator. So we have 6, and then 2 times 3, and that's 6. And so what 6 over 6 is just 1. Okay, and that's what we want. We want the number in front of our variable to be 1, because right now we say x equals 5, but that just means 1x equals 5. When the number in front of our variable is 1, it becomes insignificant, unimportant, and so we don't usually write it. So what we just did on this side is we canceled out these numbers, okay, and just left x. On the right side, multiplying a whole number by a fraction, I always find it helpful to make every number a fraction, and that way I remember numerator times numerator gives me 18, denominator times denominator gives me 2, so 18 divided by 2 is 9. So x equals 9. Okay, so a little bit of a hint of how to deal with fractions. If you didn't know, it might be helpful. Okay, or more likely that if you needed a refresher course after summer vacation. Alright, let's talk about the distributive property. Okay, now what the distributive property is really just multiplication. So number one, we have 4 times x plus 3, or 4x plus 3's. This is saying. Okay, what we're going to do is distribute. Okay, and that means give. Okay, we're going to give this 4 to the x. We're going to give this 4 to the 3. So we have 4 times x, which is 4x, and 4 times 3, which is 12. Now please understand that this is not an equation. We do not solve this. There's no equal sign. Okay, so this is as far as we can go. Okay, don't try to take this any further than that. Alright, number 2, we got some distribution, but we also have a number chilling outside here, so we need to make sure we simplify that as well. So we have 2 times 3x, which gives us 6x. We have 2 times minus 1, which gives us minus 2. And then we already have this 5 out here, so this is 5 plus, because that 6x is positive. Okay, so 5 plus 6x minus 2. And we can't add 5 and 6x because, well, they're different things. Be like adding apples and oranges. But we can add 5 and negative 2. So 5 minus 2, that gives us 3. So we have 6x plus 3. And we'll do the same thing for number 3. Now number 3 is kind of tricky, and here's why. This sign in front of 3 is negative, and a lot of people forget to deal with it. Okay, so we need to make sure that when we're distributing, we're not just distributing 3, we're distributing negative 3. Just like up here, we distributed positive 2, and we distributed positive 4, because those are the signs in front of those numbers. So here, since this sign is negative, we need to make sure we distribute a negative 3. So we have, I'll just write the 12 here because that stays there, minus 3x, and then negative 3 times negative 2. Negative times the negative gives us positive. So we have 12 minus 3x plus 6. I'm going to say negative 3x. 12 plus 6 is 18. Plus 18. Okay. Always remember to include the sign. We just got done talking about that. Always remember to include the sign in front of the number when you're distributing it. Alright, here we go. Let's go through some more problems. So we're going to use the distributive property. We're going to use what we know about solving equations to solve these problems down here. If you feel pretty comfortable with it, you can stick with me for the first problem to make sure you're right, and then try to go through the rest of them on your own, or you can just follow along with me, however you dictate. So we have 4x minus 20 equals 16. I'm going to add 20 to both sides, so 4x equals 36. And then I'm going to divide by 4, so x equals 9. And you can always plug this back in to see, does that work out? If we plug this back in, 9 minus 5 is 4, and so 4 times 4 is 16. Yes, I know that to be true. Okay. Number 2. I'm going to distribute this 2. So I have 7 plus 6x minus 4 equals 5. Alright, I am going to subtract 7. So I have 6x minus 4 equals negative 2. I'm going to add 4, and that gives me 6x equals 2. And then I need to get x by itself, so I'm going to divide by 6. So x equals 2 over 6. Now, anytime you have a fraction, you should double check to make sure that it is simplified. That means there's no factors that go into both the numerator and the denominator. But for this case, there is. Negative 2 goes into both. So I'm simplifying this. X is 1/3. Okay, and we're going to deal with fractions here. That's a way that I can make sure that you're using your brain and not your calculator. Okay, we will use the calculator later, but I want a calculator later. But I do want to make sure that you are thinking through the arithmetic, especially early on. Alright, number 3. We have 3/4 12x. Remember, with fractions, when you're multiplying them, you have to do numerator times numerator, denominator times denominator. So here we'll have 36x over 4, which can simplify. We'll do that later. Same thing here. 3 times 8, which is 24. 4 times 1, which is 4. And we'll simplify that in this next step. So 36 divided by 4 is 9. Gives me 9x. 24 divided by 4 is 6. So 24 equals 9x plus 6. We still see all that work I'm doing. Okay, good. I'm going to subtract 6 from both sides. I'll move that up here. Okay. And so I have 18 equals 9x. I'm going to divide both sides by 9. And so x will equal 2. Nope, too low. X equals 2. Alright. Last problem. If you feel like you might be catching the hang of it, pause it and then replay it after you finish it on your own. And you're feel free to do that anytime during the notes, to pause and catch back up. So here, tough part of the problem, we need to make sure that we include this negative sign. So negative 3x minus 21. Okay, now I'm going to subtract 6 from both sides. So I have negative 3x minus 21 equals 12. I'm going to add 21 to both sides. So negative 3x equals 33. And then I'm going to divide by negative 3. So x equals negative 11, because a positive divided by a negative is negative. Anytime the signs are opposite, when you're multiplying or you're dividing, that means your answers are going to be negative. Anytime your signs are the same, when you're multiplying or dividing, that means your answer is going to be positive. Alright? Okay, flipping to the back. A few more problems to solve. So you might have been saying, oh, Mr. Milton, I feel like you're doing too many steps on that front side. I feel like we should do something else before you start moving sides. And you're probably right, we should have. We're going to talk about that tool right now. We could have combined like terms. So we should combine like terms. Kind of make our problem a little bit more succinct. Okay, to do this, you put together all the terms that have the same variable, and then you simply add or subtract the terms. Okay, so for this problem, instead of adding 4 to both sides and then subtracting 10 from both sides, what we can do is we can say, okay, let's look at this. We have 5x and 3x. Okay, how many x's do we have? 8x. we have negative 4 and positive 10. What do we actually have? We actually have positive 6. Okay, and this way when I'm subtracting or adding to both sides, I only have to do, a couple steps instead of doing 4 things, I have to do 2. So now I'm going to subtract 6 from both sides, and I'm going to write this up here. 8x equals 16. Divide by 8, x equals 2. Okay, notice how we are not moving anything to the other side of the equal sign until all the like terms are put together. Okay, and so let's do that for this problem. Now, one thing that I need to make sure that you guys realize is that we have to treat these equal signs like our friends, okay? If they're on our same side, that means they're our friends. We do what they say, okay? So 7x minus 3x. This says minus, so we're going to subtract. Okay, when we deal with opposite sides, we do the opposite of what they say. Okay, but now these are on the same side, so we do what they say. 7 minus 3x. That's 4x plus 5 equals negative 19. We are going to subtract 5 from both sides. So you see now we're talking about the other side of the equal sign, so we're going to do the opposite. So 4x equals negative 24. Divide by 4, x will equal negative 6. Okay. Number 2, 5x, negative sign in front of the distribution, so I need to make sure I pay attention to that. Negative 3x. Negative times negative will give me positive 24 equals 40. Like terms here, 5x and 3x, so that gives me 2x plus 24 equals 40. Subtracting 24 from both sides, so 2x equals 16. And then I'll divide by 2, x equals 8. Okay? Alright, so a couple tricky things here. Making sure that we take into account the negative number, and then also making sure we do what the sign says since the x's are on the same side. Alright, now here's the part that you probably have been dreading, like you're really fearful of it. But, word problems. I will tell you that if there were no word problems, there would be no such thing as math, because that means that there would be no reason to know it. But these word problems, even though they might seem, a little bit unrealistic, will help lead you to some things that will actually help you out, or at least somebody out in the real world. So here we go. Let's look at these word problems. We're going to define our variables, we're going to write an equation, and we're going to solve it. So putting all the stuff together from the last few days. So together, you and your puppy weigh 128 pounds. You weigh 115 pounds. How much does your puppy weigh? So you and your puppy. So y plus p equals 128. Now this would be a tough problem to solve because we have two variables in one equation. But luckily, they say you weigh 115 pounds. So I know y is 115. We don't know how much the puppy weighs. P, y. Okay. So I'm going to say 115 plus p equals 128. Alright, now that's a lot easier problem to solve. I'll tell you that the most difficult part of these problems is going to be setting it up. So we have to think about that. Actually give yourself some time between these examples to make sure that you're giving yourself an attempt to see how close you are, if you've got it. Alright, now we have this equation, 115 plus p equals 128. I will subtract 115 from both sides, and when I do that, I'm left with p equals 13. So my puppy weighs 13 pounds. Okay, I'm okay with you saying p equals 13 on the quiz or test if I ask you that. I'm also okay with you saying my puppy weighs 13 pounds. Okay. Obviously, if you have a time constraint, I'd rather you write this and get the whole test done than write this or some kind of paragraph and not. Alright. So, going on to the next problem. 3 less than double the mystery number is 23. So, I'm going to say this mystery number, I'm going to just say n, because it's more a number than a mystery. What is the mystery number? So let's set this up. Less than. Always double check less than. always double check this. It means minus, but it's tricky because it's not 3 minus double the mystery number 2 times. Okay, it's 2 times the mystery number minus 3 because it's 3 less than this. Okay, is 23. There's our equation. So let's solve it. I'm going to add 3 to both sides. So 2n equals 26. Wrote that there. And then divide by 2. So n equals 13. Our mystery number is 13. Okay, again, no, every word problem will not be 13 just because our first two worked out that way. Okay, remember to pay attention to the process and not the answer. All right. Last problem. You order magazines from Amazon.com. Each magazine costs $5.75. The shipping charge is $2. If you have a $25 gift card, how many magazines can you buy? A lot of stuff here. So, you order magazines. Shipping charge is $2. How many magazines? So, obviously, the thing that they want to know is magazines. I think that's really important to this problem. So, we know that we have $25. That's going to be our total. Okay. Also know that no matter what we order, the shipping charge is $2. Charge that's added onto our bill. So 2 plus however many we buy from magazines. Now each magazine costs $5.75. So $2, which is the shipping cost, plus $5.75 is the cost for a magazine. We don't know how many we can buy, so I'm going to say $5.75 times magazines. And now that's our equation. Shipping plus $5.75 per magazine equals 25. Okay, because that's as much as we're going to do off this gift card. Okay, all right. So let's get the variable by itself. I'm going to subtract 2 from both sides. Gives me 23 equals 5.75m. And then I got to divide by 5.75. Okay. Alright, divide by that. For a problem like this, you could use a calculator. I kind of just did guess and check, and I found that 4. Okay. M equals 4. So it can't be $5 because that's more than $25. Can it be 4 magazines? And yeah, it worked out. 4 times 5 is 20. 4 times 75 cents is 3. So, yeah. So, again, you can say you can buy 4 magazines, or you can just say m equals 4. If you define your variable, then I know that m equals 4. Okay, notice that we're still defining our variable. We still know what everything means so that it makes sense at the end. Alright? Alright, so what we did, we solved equations. Solves for variables, used the distributive property. We also set up equations to solve. Alright? See you tomorrow.